Permutations, Part 1. There is very little that you need to know prior to this lesson, except for how to multiply. Understanding the general counting principle is helpful, but perhaps more formal than what is required in this lesson. Some familiarity with recursion is also helpful. In this lesson, you will learn to count the number of ways to put a collection of objects in order and will learn factorial notation. Suppose we have a race between two runners, one representing the maroon team and another representing the gold team. In how many different orders can they finish? In this case, the answer is simple. Either maroon beats gold or gold beats maroon, so there are two different orders. Now suppose there is a third runner from the purple team. In how many different orders can they finish? First, we must determine the winner. Suppose purple wins. We then must determine the places of the two remaining runners. Notice that this is precisely the previous example. So we have two ways of arranging maroon and gold when purple has won. There are three different runners that can win, and so our total list is 3 sets, one for each winner. And each set has 2 permutations based on the previous example. In total, there are 6 permutations, one represented in each row of the chart. We can repeat this process for any number of runners. To place 7 runners in order, we first pick the winner in one of 7 ways and repeat the process. We next pick the second place runner in one of 6 ways. Each successive selection has one fewer choice until we have arranged all the runners. The total number of permutations of 7 runners is 7 times the number of ways to permute the remaining 6, which is 6 times the number of ways to permute the remaining 5, which was 5 times the number of ways to permute the remaining 4. We continue this recursion until all the runners have been placed. The total permutations of 7 runners is 7 times 6 times 5 times 4 times 3 times 2 times 1. Since this process will be used often, it'll be useful to have a shortcut notation. This notation is called factorial notation. 7 followed by an exclamation point is read 7 factorial. It is 7 times 6 times 5 times 4 times 3 times 2 times 1. You may notice that it is also 7 times 6 factorial. For each positive integer n factorial is n multiplied by each positive integer less than n. Notice that after the n, the remainder is the product of all the integers from n minus 1 down to 1, which is n minus 1 factorial. This fact is important for many of the simplifications performed in probability. Here is an example of permutations. Suppose you are answering a matching exam where you are given 5 words and asked to match them to their definitions. Unfortunately, you didn't study and are forced to randomly guess. Because it's a matching exam, you do know that the answers to questions 1 through 5 are the letters A, B, C, D, E in some order. In how many ways can you answer the exam? This is a permutation question. You are required to list the 5 letters in order, so the answer is 5 factorial, which is 120.